Every year, the US military fires hundreds of millions of rounds of ammunition. But what happens to all those spent brass casings? Most people assume they just become waste, but they're actually worth billions of dollars. In this video, we'll show you the surprising journey of military brass from firing range to recycling facility, and how a single military base can generate over $1 million in revenue annually just from selling spent casings. The military's recycling program isn't just good for the environment, it's a massive money-saving operation that most civilians never see. Every year across US military installations, hundreds of millions of rounds are fired during training exercises and qualification courses. This staggering volume creates an environmental challenge that's often overlooked: mountains of brass casings scattered across firing ranges nationwide. At Camp Pendleton alone, Marines fire approximately 10 million rounds annually, leaving behind tons of spent brass that doesn't simply disappear. These discarded casings represent more than just clutter. When brass ammunition casings are exposed to the elements, they begin a slow but destructive transformation. The moisture from rain and soil humidity triggers corrosion in these metal components, causing them to break down and release copper and zinc directly into the surrounding environment. This leaching process can contaminate both soil and nearby water sources, creating toxic zones that extend well beyond the perimeter of firing ranges. The environmental impact isn't temporary. These metals persist in ecosystems for decades, gradually spreading through groundwater systems and potentially entering drinking water supplies for both wildlife and neighboring communities. What begins as a localized issue can evolve into a regional environmental concern, requiring extensive remediation efforts. Some military bases have faced cleanup costs running into tens of millions of dollars for contaminated soil alone. Beyond the environmental toll lies an equally significant financial waste. Each brass casing contains valuable metals that retain their worth long after the ammunition is spent. The market value of brass hovers around $2 to $3 per pound, meaning that every ton of casings left unrecovered represents thousands of dollars in potential revenue simply abandoned on the ground. Multiply this across all military branches and training facilities, and the annual loss reaches into billions of dollars of recoverable materials. The logistical challenges of managing this waste stream are immense. Military installations are scattered across the globe, each with different training schedules, terrain types, and access limitations. Some remote training areas make regular collection particularly difficult, while others accumulate such density of spent casings that mechanical collection becomes necessary. Standard waste management protocols simply aren't designed for this specialized form of metal waste, requiring custom solutions tailored to military operations. These uncollected casings create additional safety hazards that compound the problem. Ranges with accumulated brass can become dangerous environments where personnel might trip or slip during training exercises. More concerning is the potential for misfired rounds or live ammunition to mix with spent casings, creating unpredictable risks. Without rigorous collection and sorting protocols, these components could potentially be accessed by unauthorized individuals, presenting security concerns beyond the environmental implications. The scale of this challenge seems almost insurmountable. How does an organization as vast as the US military manage billions of tiny metal components scattered across thousands of acres of training grounds? Traditional waste management approaches would require enormous labor resources and still likely miss significant quantities of material. The sheer volume demands a solution that's both environmentally responsible and economically sensible. This is where the military's comprehensive recycling program enters the picture. What began as an environmental necessity has evolved into one of the Department of Defense's most successful sustainability initiatives. By implementing specialized collection systems at firing ranges, the military has transformed what was once considered a waste management liability into a valuable, recoverable asset. The process starts right at the source. Modern firing ranges are now designed with brass collection in mind. Specialized containment areas and collection systems make gathering spent casings more efficient, while mobile collection units can be deployed to more remote training areas. Once gathered, These casings enter a sophisticated processing system that sorts, cleanses, and prepares them for reintroduction into the manufacturing stream. These mountains of collected brass don't simply transform themselves from battlefield waste to reusable material. Ever wondered how the military safely processes millions of potentially dangerous casings when even a single live round mixed in could cause catastrophic failure? The answer lies in an engineering ecosystem most civilians never see. After collection, the real technological marvel begins at munitions depots across the country. The first critical step involves meticulous sorting, not just by appearance, but through sophisticated systems designed specifically for military ammunition. These aren't simple conveyor belts with human sorters. The military employs advanced spent brass sorter devices capable of processing over 5,000 casings per hour with remarkable precision. These sorting machines don't just separate brass from other materials, they perform multiple functions simultaneously. They evaluate whether a bullet has been fired, accurately identify different calibers, and flag anything suspicious that requires human inspection. This automation dramatically reduces processing time compared to manual methods that were standard just decades ago. Safety remains paramount throughout this process. One of the most critical functions of these sorting systems is identifying and removing any live ammunition that may have accidentally been collected with spent casings. Even a single overlooked live round could cause catastrophic accidents during later processing stages. These sophisticated machines use various sensing technologies to detect unfired primers and separate these potential hazards for special handling by trained personnel. Once sorted, the brass undergoes thorough cleaning to remove accumulated dirt, debris, and gunpowder residue. This cleaning process must be thorough enough to prepare the brass for recycling while being environmentally responsible with the removed contaminants. Non-brass elements like steel casings or components are also identified and directed to their appropriate recycling streams. Nothing goes to waste in this system. The next stage involves processing through deformers, specialized machines that reshape the spent casings to prepare them for melting. This crucial step compacts the brass, making it more efficient to transport and process. The deformers crush the casings in a controlled manner, maintaining the material integrity while reducing their volume and preparing them for the next phase of recycling. Quality control measures run throughout the entire process. Military specifications for recycled brass are exceptionally strict, since this material will eventually become new ammunition upon which soldiers' lives may depend. Each batch undergoes rigorous testing to ensure it meets these exacting standards before being approved for reintroduction into the manufacturing stream. The attention to detail pays off. This sophisticated processing system achieves an impressive 99% material recovery rate. What was once considered waste is transformed into high-quality raw material ready for its second life. The brass leaving these facilities is virtually indistinguishable from virgin material in terms of quality and performance characteristics. The environmental benefits extend beyond just keeping brass out of landfills. By reprocessing spent casings, the military reduces the need for new mining operations to extract copper and zinc, the primary components of brass. This conserves natural resources and eliminates the substantial environmental impacts associated with metal extraction and processing. The entire system operates with remarkable efficiency, considering the scale of the operation. From collection to sorting, cleaning, deforming, and quality control, each step has been engineered to maximize throughput while maintaining strict safety and quality standards. What might appear chaotic, millions of spent casings of various calibers mixed together, becomes organized and valuable through this systematic approach. While the engineering achievements are impressive, the financial impact of this recycling program reveals a remarkable economic transformation. Military bases aren't just reducing waste, they're creating value. A single installation can generate over $1 million annually by selling spent brass casings to manufacturers, turning what was once considered trash into a significant revenue stream that supports critical operations. The economics make perfect sense when you examine the full picture. Military budgets face relentless scrutiny, with ammunition consistently ranking among the most substantial recurring expenses. Without comprehensive recycling, these spent casings represent not just environmental concerns, but billions in potential value literally thrown away. This recycling initiative fundamentally changes that equation. What makes this program particularly effective is the quality retention of the recycled material. When properly processed, recycled brass maintains 99% of its functionality compared to virgin material. This near-perfect preservation of properties means manufacturers receive a product virtually identical to newly mined metals, but at a significantly reduced cost, creating a powerful economic incentive for both the military to collect and companies to purchase. The journey from recycled brass to new ammunition involves sophisticated manufacturing techniques. Once sorted and cleaned, the recycled brass undergoes a remarkable transformation at ammunition production facilities. The process begins with drawing the casing material into cups, which are then formed into casings through precise stamping and drawing operations. These operations require specialized machinery that shapes the malleable brass with exacting standards. Perhaps most crucial to maintaining the material's integrity are the heat treatments. Recycled brass undergoes specialized thermal processing, including annealing, normalizing, and sometimes quenching and tempering. These treatments reduce internal stresses created during the forming process and ensure the final casings will perform reliably under the extreme pressures of live firing. This technical sophistication explains why recycled brass performs so consistently compared to new material. The molecular structure remains fundamentally unchanged through these carefully controlled processes, preserving the metal's essential characteristics, while significantly reducing production costs compared to extracting and processing new raw materials. Installations like the Bluegrass Army Depot in Richmond, Kentucky exemplify this economic transformation in action. Here, teams renovate artillery projectiles like 155mm shells used in systems such as the M77 howitzer and M109 self-propelled howitzer. Their process includes methodically sandblasting each shell to remove rust and old paint before reapplying precise coatings to meet stringent military specifications. The different colors and markings added to each shell, including lot numbers, manufacturer information, and production dates, serve dual purposes of inventory management and helping soldiers quickly identify munition types in the field. The revenue generated from brass recycling creates a virtuous economic cycle. When bases sell their recycled brass, the funds don't disappear into general accounts. They return directly to military installations, helping finance essential training operations that would otherwise require additional budget allocations. This direct reinvestment mechanism creates powerful incentives for bases to maximize their collection efforts, knowing the recovered materials directly support their missions. From a broader perspective, this recycling program represents a substantial contribution to military fiscal responsibility. When calculated across all branches and installations, the annual savings reach into billions of dollars. Funds that would otherwise be dedicated to raw material purchases and waste management operations. These savings become particularly significant when considering the scale of military ammunition usage and the corresponding volume of potentially recoverable material. The economic dimension extends beyond direct savings. By reducing the need for new mining operations to extract copper and zinc, the military simultaneously decreases its environmental footprint and insulates itself from market volatility in raw material prices. This strategic approach to resource management protects against supply chain disruptions while demonstrating responsible stewardship of taxpayer dollars. The military's brass recycling program has transformed environmental stewardship into a premier sustainability initiative within the Department of Defense. Rather than simply addressing waste management, this program demonstrates the powerful intersection of ecological responsibility and fiscal prudence. What makes this program particularly remarkable is how it combines cutting-edge processing technology with methodical collection systems to reclaim what would otherwise be lost resources. The success extends beyond the immediate financial benefits, creating a circular economy that reduces the military's overall environmental footprint. This hidden aspect of military operations provides a compelling blueprint for other industries struggling with valuable waste streams, proving that sustainability can effectively coexist with operational efficiency.